So, good afternoon, everyone. On behalf of Science City, I welcome you all in today's webinar on Sustainable Development Goal 11, that is Sustainable Cities and Communities. And the topic is Smart and Resilient Cities. So, today we have with us our expert, Dr. Ashok Sharma, former Member Secretary, Himachal Pradesh State Pollution Control Board. Sir, I extend a very warm welcome to you and for accepting our invite and for thank you for agreeing to interact and to share your views with our participants. So very briefly, I would like to share with you that Science City has formed 43 SDRs clubs all over Punjab, wherein students from government and private schools, they actively participate in all the activities that we organize from time to time. Basically, we organize two activities twice a month. So in which we cover different SDGs. And today also some students will share their idea on Make My City Smart, applications of IoT, that is Internet of Things and Artificial Intelligence. So without any further delay, I hand over this platform to you for another 25 minutes. So please.
Thank you, Loveleen, and welcome all the students. You would excuse me for little interruptions because today I'm suffering from COVID and it's a bit difficult to speak. But nevertheless, I derive energy from the young students and I should be able to make it. Let me start with saying one thing. Do not be overawed with terminology. This sustainability, smart city, these are jargon which make things a little difficult to understand, and generally for a student it becomes a little overawing to listen to these words. Basically what it means is how to make our lives simpler, smarter, and sustainable. Sustainable means that you're not consuming all the resources today and leaving nothing for the next generation. So that is sustainability in very simple words. And when we say, smart, again, this is a word which is very confusing. What is smart? I might say Harmanpreet is smart girl. So it is a relative term. Why not? Radha is also smart. Or for that matter, any other one of you is smart enough? It's always a relative term. But then, how we call a city smart? It's older days when we used to travel abroad. People used to go out and come back to tell us, oh, US is great. England is great. What was great about England? Because they have underground trains. Today we have metro rails running in India. So it's no longer smarter for us. We are as smart as they were. So smartness is again a relative term, and so is sustainability. All these terms are very flexible, and we can always optimize them. We may not be the best, but we can always strive for betterment. Now, earlier, if I needed money, I have to go to bank, travel to the bank, make a check, stand in the queue, and take the money. Then a stage came, we talked about ATMs. So you push your card, get the money. Easier, smarter, right? Now we have a mobile phone. You just phone pay. Smarter, so far the smartest. But this may not be the end of it. The time will come where I will think that I have to pay $100 to Radha, and the moment I think, the command goes and $100 transferred from my account to Radha. That will be smartest. Is that right? So no, don't be frightened by the word smart or sustainable or any other jargon which people might try to use. But the objective is that we design and develop cities where life is easy. We use minimum resources and maximize our pleasure. Now, all of us use in our daily life water, right? So older days, we never bothered. We just take out the water from the well and use it as much as we liked. Today, you have to pay for water. It comes piped to your house. So let us use it in a scientific manner, or let's say in a wise manner, that with minimum water, we do everything that we need, satisfy our needs, still not throw. And if we throw, we recycle it if possible. So maybe, I'm using water in the kitchen. From there, when it goes out in the drain, it's used for gardening. It's a secondary use. It is smart. I have a roof on top of my house. It collects rainwater. I channelize it, store it in an underground tank, then again pump it out, use it for gardening. It's smart. We call it rainwater harvesting or whatever we may call it. These are technical names. Basically, we applied our mind to make our lives better. That is smartness. I lived in Tokyo, city of Japan, and I noticed, just like us, we catch local buses. So I go to catch a bus. So I only has to check my destination and the route number. And on the display, it tells me how many stops behind the bus has already reached. It's not only that I know that my bus comes at 9:50. Right now it's 9:40, 10 minutes to come. But I can also see that it has reached 2 stops behind. And sharp 9:50, it reaches me. The smartness is that I'm able to see that it is coming, right? I gave you the example of ATM, the example of money transfer, digital transfer. These are all smart ways of living. Now, when you live in multi-storied buildings, you're using water. How do you use it? Push it to the top in the storage. And then the person who lives on the ground floor, he gets enough pressure and he gets all the day supply. But the one who lives on upper floors, they don't get it because the pressure is low. If the people down below, they start using it in a manner which is indiscriminate, the people living above would not, they'll be deprived of it. And there may be fights, conflicts, and disputes. So you have to think how much pressure to be maintained. And then there has to be a system which automatically maintains or varies that pressure so that it reaches everybody very comfortably and very accurately. And also it is built accordingly. Let me also give you another example. While living in Japan, I found my water bill was the highest. My electricity bill was less than water bill, and my gas bill was the lowest. In India, it is other way around. It was a bit surprising. Why it is so? Well, gas is available in plenty there and supplied piped gas. It's not like cylinders we use in India. It's like piped gas supply in Bombay or in Delhi. So it works out cheaper. So gas becomes cheapest. Electricity is slightly more expensive. But water is most expensive. That is surprising. Why? First of all the water that comes into your tap has to be drinkable. It has to be absolutely A grade. So it is expensive. Second thing, when I use a flush, the water which comes in is an expensive drinkable water. It goes into the flush, and from there, it goes out for treatment. It goes into a sewage treatment plant for treatment. That their water is purified again and is circulated back. So the moment I use that flush, water coming in, I pay for it, the price of water. Water going out, I pay the cost of treatment of that water right there and then. So the cost of water becomes the highest. And when it is the highest, then I am very careful to minimize the use of water. And invariably, people who use water for flushing, they don't let the water go directly into the cistern. They have a tap above the cistern, and there they use it for a wash basin. Wash their hands, and it goes into the tank, then it is flushed out. So a double use for that water. Everybody starts thinking how best to utilize the resource. That is important. And with small innovations, let me not burden you with the examples abroad. In Shimla, we tried water conservation in the hotel industries. We have so many hotels. Every hotel has something like 30, 40 to 100 rooms. And everywhere people who come, they misuse water. So one small example, somebody, when we were doing a brainstorming and young people like you were giving suggestions how to save. Very interesting. It's not the experts giving suggestions. And one young person, he said, look, this is 1 liter bottle. Let us fill it with water. Okay. Then put it inside the cistern of the flush. So every time someone uses that flush, it will use 1 liter less. If this is used 20 times a day, 20 liters saving from one system. And if there are 100 toilets in that building, you can imagine how much is the saving. So 10,000 liters every day is smart. This is smart. So smart city is not something very strange. It is something where people use their brains to improve their living conditions. It can be smart electricity, which includes metering, which includes many other things. It can include solar lighting, right? And just like that, it can be smart mobility. You're catching a bus, yes, you're catching a train, or if visit countries like Switzerland, where there are a lot of congestion on the roads, and the cities are small. So they have overhead transport, which means you have cableways. So at destination from point A to point B, you travel above the crowd. Sit in the cabin, and you're going in a ropeway. So ropeway is a normal mode of transportation there. We have a lot of buses which can create a lot of pollution. So they have system of having overhead conductors where electricity is supplied to the bus for its mobility. So an electrical bus is zero discharge, zero emission mobility. So it is smarter. So everywhere where you can make some difference, either in terms of cost, or in terms of convenience, or in terms of time saving, or in terms of burden on environment, it is smart. And many parameters. Sometimes convenience itself is a great thing. You want to be, first of all, comfortable and convenient. But then you don't want to pay through your nose. So it must be affordable. And it must not impact your environment in a manner. Many years back, if some of you remember, when there used to be electricity shortage and there used to be power cuts, people had small Honda generators. So you start them, they supply electricity, lighting in the shops. But they created so much of pollution. It was difficult to stay near them. Although the shopkeepers were still running their shops by using them, but they were spoiling the environment so badly, the customer might not like to stay there a minute extra. So you got to address environment also, amongst other things. You must maximize the use of resources. If I use electricity, I use minimal. If I use water, I use minimal. If I create a waste, it has to be minimal. And if at all it is created, it must be recycled or reused. That is smartness. And this same concept, when you translate in terms of environment, this is called sustainability. If I'm not using away all the water, if I'm not using away all the minerals, if I'm not using away all the resources available today, I can leave something behind for the children and the next generation. But if you take out all the coal, burn it and use for energy, you take out all the water from the ground and then make it deplete, you will leave nothing behind for the next generation. Or if you create such a bad environment around you, it's not livable. Again, who's suffering? The next generation. So sustainability is simply understood that we leave behind something for our next generation, for posterity, as good or maybe a little better than what we inherited. So these are very small 3 definitions which I thought we should talk about, and then we can go for the a little formal presentation in a 1 hour discussion with you, where I would like to hear you also more than I speak. I'm confining myself to technological interventions for smart cities, not the policy matter nor the political agenda, but for very simple thing. Today you hear the government saying that we will make 500 smart cities, we'll make 1,000 smart cities. When they will make, or whether they ever be smart enough, we don't know. But okay, it is a very catchy word, which it's a very good slogan to say that we'll have so many smart cities. But if we adopt these principles and practices in our life, our own place will become smart. Nobody has to create a smart city for us. So let us go to our formal presentation. If I can do that, Evelyn, please guide me. Share screen.
Sure, sir. You can share your screen.
Okay.
Yeah.
And
the screen is visible to us.
all right. Now. Okay. Can you see this? Or?
Yes, sir. It's visible.
All right.
So please
is
put
it
it on full screen mode.
Full screen mode.
There's a tab.
I can see this, I suppose.
On
yes.
the top of the. Yes.
All right.
Yes, sir.
All right. Okay. This is now. I confine myself to innovative technology interventions for smart city management. So whatever I explained to you, what is a smart city and how we can make our lives smarter, for which we need interventions. Like when I said digital economy, it is a technology which has made it possible. When I say electrical vehicles, or smart mobility. It is again a technology which made it possible. So there are certain technologies which are very important and critical to smartness of a city, and which are generally common to all cities. We will only talk about those things. We are not talking about a particular city. We're talking in general, that what are the interventions which can matter in terms of planning or managing a smart city. So our major technology initiatives can be: one is sensors and artificial intelligence, right? Now, when I said, you can look behind two stages of bus stops where the bus is actually there, it is coming to take me. Well, it is the first step, that sensors and artificial intelligence is making it possible. Big data and applications and cloud computing. Don't be afraid of these jargons. They are all big words, but actually nothing. They are very simple things. So whatever information we have together, we collect it, and then we decide, okay, it will guide what action is required. That is what we call the cloud computing. We collect that data, we collect the health data, how many people are sick, how many hospitals we need, right? How many people live in the town, so how much water do we need, how much of space we need per person, how many restaurants would be required, how big market would be required. So everything is collected, is designed or planned by collecting basic data about the place. So when you have a multiplicity of data and put them together in the context of a limited area, that is called a big data application. Then blockchain technology. These are all jargons. Don't you can even forget them. But I'm trying to just list them, that okay, these are things which work. Now, sustainable mobility and traffic management, I mentioned to you, is very important. Because if you electrified your bus fleet, you have saved the citizens from poison. So much of smoke coming, infecting your lungs. You saved of that. Is the biggest thing one can do. So that is really smart. Then sustainable waste management infrastructure is the most important. In a city planning, well, it's very simple. You drink a can of Coke and you just throw it, or put it even in a bin. It is going into waste. It has to be received by the environment, and you're putting a burden on the environment. So all of you try to understand there are two ways of impacting your environment. One is we took out the alumina, the mineral, made aluminium, made a can from the aluminium, filled it with Coke. It came to the consumer. The consumer drinks the Coke, throws the can. Now, first place we dug out the mineral, converted it into metal. Now you thrown that metal, it will go back to the soil. So you're impacting in two ways. One is you're depleting it of nature's resource. Maybe someday no aluminum ore be left for the next generation. But second thing is you are dumping it back into landfill. Again, you are impacting the environment doubly. The third option is that those cans are recycled to make cans again. So that is where sustainability comes in. And sustainability has got a lot to do with smartness. So when you planning a sustainable, or let us say smart city, in its management, most important thing is the sustainable waste management infrastructure, which means how will the municipal organization collect waste from you? What will do with the waste? How will it safely dispose it or recycle it? That is called waste management. And how sustainable is that waste management is very, very important. Normally what we do is outside the city, you find some space which is low lying and you start dumping there. After a few days from that ditch, it becomes a mountain. It's a mountain of garbage. Then you put some soil, topsoil, and just beautify it and say, okay, taken care of it. It's the worst type of waste management. But sometimes we have no other option but do that. A better course would be that when you're sending the waste for dumping, take out whatever is recyclable. All metals are recyclable. All glass is recyclable. Many of the plastics are recyclable. So if you're able to sort them, if you're able to segregate them, so segregation of waste becomes a very, very important component of waste management infrastructure. And whatever cannot be handled, now it can again be split into two. One is compostable, one is non-compostable. So if it is compostable, make compost. It will be used in agriculture. But if it is not compostable, then again you have to think either it is combustible or non-combustible. So if it is combustible, you can send it to an incinerator, burn it, use that heat to generate steam and in turn generate electricity. Again, it gives you back something to the society. And finally, what is left would be very small in size. So if you're sending, let's say, 100 tons a day into the dump, by doing this, on an average, you will be sending only 15 tons to the landfill. 85% will be either recycled, reused, or maybe reconverted into one form or the other. Technically, my belief is that there is nothing which you could call a waste. Everything is materials. If you have a plastic bucket, you used it for long, it broke, it is still plastic, it is material. You may call it waste because you think it is not usable, it's waste. But it has plastic. If that can be recycled to make anything, then it becomes a resource. It becomes a raw material. And what is raw material? Raw material is resource. So it is a fantastic example that you can send it for recycling. In today's world, there are technologies which can convert the plastics into mineral oil. All plastic is polymer. I hope some of you are able to understand what is a polymer, but never mind, don't bother your head. It is something like, from a petroleum liquid, you created a solid plastic by polymerizing it. Polymerizing is a process where it becomes close-chained and it becomes thick, heavy, solid. So everything which is polymerized can also be depolymerized. So once the plastic has lived its life, you can depolymerize it. It will become a liquid again, and it will be like a combustible fuel oil, just like diesel. So there are technologies very easily available today where you can segregate your plastics, convert them into diesel oil, convert them into furnace oil, and you can use them for either heating or for generating electricity. So these are possibilities. So sustainable waste management and sustainable mobility make more than 50% of the components of smartness in any town. Now, same is true of water quality management and conservation. So water quality has to be fit, as I said, where I was paying 3 times on my water consumption in Japan. That entire water was drinking water standards. So it is possible only in very affluent countries. But many countries have a policy where you have a tap water which is drinkable and you have a tap water which is for other uses, which is a B grade water. In our country, we have the policy of drinking water in the tap, but it is actually B grade, not A grade. The difference lies there. So water quality management and conservation both are to be taken together. Conservation, I already given you an example of the rainwater harvesting. Or let me say, this is at the receiving end. You received rain, you collected it, you stored it, and you are reusing it. Second thing is the piped water which is coming to you. If instead of a tap you use a shower, you consume less water. Have you noticed, all of you? You have showers at home, many of you. If you use a tap, stand below this and take a bath, there's a lot of water gushing out. But if you had a shower, it sprinkles water, and you're using generally 1/3 of the water quantity as compared to the tap. So use of shower is by itself is a water conservation method. Use of water jets, again, a conservation method. Then very similar principles apply to energy efficiency and sustainability. We used to have bulbs, electric bulbs, which were in an average room. A 100-watt bulb was insufficient. So you had generally 200 watt per room. Then we started using CFL. So when you started using CFL, 2 lamps of 15 watt were good enough for the same room. They'll give you the same light. Because the incandescent lamp, which you were using in the past, the electric bulb, which you call it, was generating more heat than light. And the CFL is generating more light than heat. But then we also found that it had a limited conservation, but the material used were hazardous. It used mercury. So it was done away with, and we started using LED lamps. And an LED lamp, the same job would be done by a 10-watt bulb, which was 100 watt on our original bulbs. So 90% of energy saving. Older days, the refrigerators, and if we compare them with the refrigerator today, the average reduction in energy consumption is 85 to 90%. So again, everywhere we are aiming at 80 to 90% of saving, which we have already achieved. And there is no limit to it. We need to think more and save more. All right. Now, air quality assurance and noise control is very important, which brings us to the eco materials. If our houses are built of materials which can contain vibration or which can make your building soundproof, without extra cost, I think a major objective is achieved. And a very good example of it is fly ash bricks. These days, when we get a lot of fly ash coming out from the thermal power plants, and we have no space to dump it. So an alternative use for that ash is to make bricks. And those bricks are insulating in nature, more insulating than our bricks, regular bricks. They're cheaper and they're soundproof and they're lighter in weight. So our buildings weights are less. Your sound proofing is better. Your insulation is better. And better insulation means, again, better energy efficiency. So all these things are interrelated. So from simple air quality assurance and noise control, you come back to, again, energy efficiency and sustainability. All these things you would see top to bottom, they are very much interrelated with each other. Then sustainable infrastructure and futuristic materials. I will be giving you a few examples. I'll show you in times to come, but most of them would be the insulation quality. Then is food security, vegetation, and healthcare. For any sustainable city, for any smart city, you must be able to have a garden in your balcony, in your backyard. If you don't have a backyard, it may be in your balcony, maybe your rooftop, so that you can get your daily needs, small kitchen garden, what you call it, within your control. Then community services, recreation, infrastructure has again to be smart. And for doing all this, you need tremendous amount of awareness and training. Train the citizen, train the workers, train the management. So human resource management is a very big tool that has to work behind it. Please, if you have any question till now, we can break and take it. Otherwise, I'll proceed further. Now, for doing all these things which I spoke to you, we have to choose some key technology initiatives to meet all this. So, smart water quality management, smart waste management technologies, smart materials, smart energy management, renewable energy, solar energy initiatives, smart tourism and recreation, smart mobility, smart surveillance and coordination. Now just think over these, and if you can give some example or you can give some suggestion, I would welcome it. Particularly smart tourism, particularly smart surveillance and coordination. What do you say about this? In very simple example, surveillance, what do we mean? That we have cameras all around. We call them security cameras. Do you like them? The young people don't like it because it inflicts their privacy. You want to enjoy, you want to move with your boyfriend or with your girlfriend. And if you're watched by a camera and some cop is watching it, you don't like it. I won't also like it. Why should anybody intervene with your privacy? So we have to have surveillance also, but we must maintain the privacy. So it has to be a balanced approach. If you have a sensor in your lift, which is a smoke sensor, it will control the smoking. Somebody is trying to smoke inside the lift, the alarm will be on. So the lift will stop. So it is the first thing which has had sensors and intelligence, artificial intelligence. It has not interfered with your privacy, but since you smoked, it objects. And next time you shall not do it. It will work very well. I would like to pick up one or two points out of these. One of them is, well, renewable energy and solar energy initiatives. Very important thing. To my mind, this is closest to me, and this is something you can all go home and start working on it. Tell your parents this is something which they must do immediately. All of you have a rooftop, right? Many of you have your own building, your own house. And if you want to make another floor on top, you have to get an approval from some authority, whether a municipal organization or a town planner. But if on the top of your roof, you make another floor which is having a solar panel as roofing material. If you put solar panels on top, you don't need anybody's approval. You will have a space to sit below that. You will have space which is yours, added to for your use, and you will get electricity generated from the sunlight, which can be fed to your energy meter. So these days their meter system are two-way. When you are generating energy, it gets supplied to the electricity board. So if we supplied 2 units and we consumed 4 units, we will pay for 4 minus 2, which means it gives you money directly. It saves your energy bill. In Punjab, you can save your energy bill up to 70%. But in Chandigarh, you can not only save 100% on your energy bill. If you have supplied extra energy, maybe, during summer you go to some hill station and stay there. Your house is locked. So you are generating energy and giving it to the electricity authority. And it is being billed to them. So you can carry forward that benefit when you come back. It will be deductible from your bills. So which means you may not only get 100% saving on your electricity bill, maybe sometimes you are paid back something for doing this initiative. And it is a one-time investment. It is a lifetime investment, I would say. It gives you money. It is smart. Again, I come back to the same word. What is smart? It's very confusing, but this is smart. You're getting benefit. You got paid back for whatever you invested, and you continue getting it without doing anything. This is smart. So this is one which I wanted to particularly touch, and you must think. And you see, with the new technologies which are coming up, now we have something like, you can see this behind me, there is this louvers. In some countries, they have solar panels on these strips. So they not only cut out the heat or the sunlight from coming inside the house, but they also generate electricity. So not only your roof, your windows can also generate electricity. In your shopping malls and commercial establishments, practically all the glass which is there should be replaced by solar panels so that they generate energy and they become zero energy buildings. It's a very new but very popular concept, that sustainable buildings. Sustainable buildings, after all, make a sustainable township or a sustainable city. So each building has to be made sustainable. And how can it be made sustainable? You use eco materials. You're using good quality insulation so that you don't have to spend on air conditioning or spend minimal on the air conditioning. And then you can use a lot of paneling, solar paneling for generating energy and make standalone buildings which do not even need external power connection. It is possible. So we go to the next. Smart water quality management. We said that we need smart water quality management, smart waste management, smart materials, smart energy. But then let us take one by one. The smart water quality management would comprise of how many things? Water treatment technologies. I do not know whether boys and girls, you have seen a sewage treatment plant. It is very important to see that because it makes you wiser. You start thinking. Then at home, we consider it very easy to flush it and then forget it. Well, where does it go? What all is done to that by the municipal authority? It's a very complex process. A very interesting example of sewage treatment I have seen is Paris. City of Paris is considered to be one of the oldest planned cities. And below the entire city, there are tunnels and walkways which connect all parts of the city to a central water treatment, sewage treatment plant. And it is very amusing and astonishing that it is a tourist spot. People who go to Paris, you have an organized visit to the sewage treatment plant. And it is very interesting. It's not stinking. First of all, let me dispel your fear. It is not stinking. It is quite okay. You can walk through and you can see what all is done to that water. But coming back to water treatment technology is the first line here. Water treatment basically is nothing but oxygenating water. You supply more and more of oxygen to the water. So whatever are the pollutants there, they will be oxidized and they will settle down as sludge and clear water will emerge. All the biological pollutants, they take away oxygen from water and make it a dirty water. But when you supply a lot of oxygen to that water, they get oxidized, they meet more than their requirement of oxygen. And those biological ingredients, they decompose through oxidation. And the crux of the water treatment technology is oxygenation or oxidation. And for which what we do is supply oxygen. Now you can supply oxygen in a variety of ways. You can have a surface aerator which splashes the water. And when the water splashes, it gathers air from the surrounding, and air has 20% oxygen, 21% oxygen. So that oxygen will go into the water. But mind you, it is only surface aeration. It is not treating water down below. So a better method would be that we have air supplied from the bottom through the pipeline and the jets. So a lot of water, the air will come from below, leave up, and while it is passing through that water, a lot of air oxygen will be absorbed by that water. So it will be treated faster, better than the earlier surface aeration. But then the time taken by the air bubble from bottom to top will be very short. So if I put a diffuser, means a sieve kind of thing, very small holes. So very small bubbles will come out. So those bubbles, when they go up, they will have water resistance from the water. So they travel up slowly. And because they travel up slowly, and one continuous stream of air is split into many bubbles. So the surface area of air in contact with water also increases tremendously. So it becomes a more effective way of transferring oxygen into water. So that's where the technology comes in. So instead of a surface aerator, bottom aeration, instead of using a jet, using a diffuser, from using a coarse diffuser to a fine diffuser, again, each time, the smaller the air bubble, the more time it takes going up, greater is the area. So it is more effective. And as we go down and down and down, we go into nano-sized air bubbles. At that stage, there is so much of resistance of water allowing the bubble to travel upwards that the bubble doesn't go up. It keeps traveling within the water. So period of residence of air from, let us say, 5 seconds or 7 seconds, now it becomes maybe 7 days. So the efficiency of transfer is very high, right? So what have we done? We have only applied our mind that rather than supplying the same air in a continuous manner, we split it into nano-sized bubbles and then released it. It's very similar to when I said you are using a shower and you are using a tap. Shower uses less water. So here, it uses less air to do the same job. So the air transfer, which would normally be 18 to 20%, it goes as high as 90%. So your cost of treatment of water is lowered. Your efficacy of treatment becomes very high. So that is what is called technology. So water treatment technology is very important. And now, you see, it has treated water. It settles down your impurities. It removes the dissolved impurities into sediment. But then it can contain a lot of bacteria. And bacteria is harmful. You cannot remove it. So that is where the disinfection becomes important. Most of our water supply schemes in cities so far relied on bleaching powder or chlorine to disinfect water. And chlorine, mind you, is very, very harmful if it goes into our intestines. It has very damaging effect. It is like drinking very mild, very dilute hydrochloric acid. So it is really not recommendable. But on the other hand, if we use ozone is O3. O3 means oxygen is O2 because two atoms of oxygen, they club together to make one stable molecule called O2. But this is O3, so it is unstable. The moment you release ozone inside the water, it splits into O2 and nascent oxygen. And nascent oxygen is a very, very strong oxidant. It kills all the germs, all the bacteria, all the viruses, all the vectors. It's 100% disinfection across the board. It is cheap, it is effective, it is safe. You the byproduct at the end of it, you're left behind with only oxygen. So you are enriching the water with oxygen, which is good, which is not bad. And you are also getting rid of the biological contamination of water. So ozone technology and bubble technology are very important. Water conservation, recycling, we talked about. This is a very common sense matter that if you are using less, you're using shower, you are using nozzles, you are reducing the consumption of water. Let's say in a kitchen tap, you put one small nozzle. It does the same job with a pressure jet. And with less water, you are able to wash vegetables or do whatever you want to do. So conservation and recycling of water are both very important, goes without saying. And there are endless examples of it. But most strategic is water pricing. In India, we do not bother about water consumption. Why? Because water is cheap. When I went to Japan, as I told you, I was shocked that the water bill is the highest. And I was explained why it is highest. But here we don't care because water is almost cheap, very nearly free. And the cost of purifying water to bring it to drinking standards is very high. The cost of treating the sewage water to get normal clean water is also very high. So what we are doing is subsidizing that cost by not charging people and spoiling their attitude. They don't care wasting that water. Go on wasting it. So if the pricing is a bit higher, people start thinking in terms of saving that price. All of you are very comfortable with energy saving. In every household now, the old bulbs are not seen. You're using LED lamps, which are 5 watt to 15 watt maximum. But earlier we used 100 watt, 120 watt bulb in the same room. So because of the high cost of energy, people are really very willing to adopt to the energy conservation method. But in case of water, there's not much incentive, there's not much of saving. Water is already very cheap. So as a policy, it is important to price it a bit higher. Then rainwater harvesting, we already talked about it. But most important is groundwater recharge. See, all of us who know old times, there were wells which you dig and open, you get water at certain, let's say, 70, 80 feet down, you get water and you can just pull out in a bucket. But today, you go 200 meter down and you don't get water. So the groundwater is receding. So it is very important to recharge groundwater. So when we are doing rainwater harvesting, it may be a good idea to build up recharge structures where water slowly seeps down into the soil and it compensates for the lost water. So because of the overdrawal of water, the level was going down, it will slowly bring it back. So groundwater recharge is also very, very important. See, I am trying to make these concepts clear to you. Do not bother if you forget a few of them or don't truly understand each one of them. On the whole, we need to build a picture before you. So that next time when somebody talks to you, you are on the same or similar wavelength to discuss this matter and maybe come back with some good suggestions. And the best suggestions come from youngsters only. Now, last of them is water bodies management and recreation. So if I read this word, water bodies management and recreation, it sounds very, high sounding, but it's nothing simple. If those of you live in around Chandigarh, we know there is Sukna Lake here. If you go to your village, there is a village pond there. They're all water bodies. So these water bodies, their water quality is over the years, it deteriorates. In the village pond, the buffaloes are bathing. It becomes bad. If you go to Sukhna Lake, it is a lake which is a mud water lake, I would call it. It doesn't have a presentable. We enjoy boating all right. We can have a walk. There is fine. But that water, you cannot look below and see a fish because it is opaque. It is so muddy. It has such a high degree of suspended material in it that you can't see through. So this is a sick lake. It has to be managed. It has to be recreated. It has to be, converted into a truly good resource. And sometimes you can even think of making it a source of drinking water for the entire city. So how to do it, we can maybe a little later talk about it when we talk about principles of lake restoration. I said we need to restore this lake, Sukhna. So when I say Sukhna, it is an example. It can apply to any lake. All big cities have lakes. If you go to Udaipur, you have all over lakes and lakes and lakes. Here we have just one man-made lake. But when we say we want to restore it, what does it mean? First thing is preserving a good water quality and eco-integrity. What is eco-integrity? It should have some aquatic life. There should be some fishes. There should be, a visibility. There should be some good aquatic plants inside. It must have an ecosystem where the conversion of CO2 into oxygen also takes place. So for growth, all plants need carbon dioxide and sunlight. Here the sunlight doesn't penetrate down to the plants which are there in that lake. So first of all, it must become transparent. Then restoration of native species. There used to be certain species of fish which are now vanished. Then avoid non-native or invasive species. But it's not that if it doesn't have fishes, so bring some fishes and put them there. No, that may not work. It must have those species which are very natural in that place. Then we need to see what is causing the degradation of lake. Luckily, in case of Sukhna, it's only silt which is causing degradation. But in many lakes, a lot of sewage is thrown. That causes degradation. Industrial waste is thrown. That causes degradation. Fortunately, it's not so here. Then you deploy natural fixes and bioengineering, anticipate future changes, design for self-sustainability. Now, these are technical jargon. Do not bother about them. Then develop clear, achievable, measurable goals. What do I want? I want a blue lake. That's an objective. This is clear. From this mud water, next time when I come, I want to see this is blue water. It is transparent. Some plants are visible from below, coming up. Some fishes are moving around. I can see them. That make it a lake, not a reservoir. So all these goals should be clearly achievable and measurable. Then we build an interdisciplinary team for action. Okay, let us do it. And how we do it. If there are motorboats, replaced with solar boats. Okay. Then prevent the entry of wastewaters and runoff. Means no sewage water coming inside the water body. Or let us say, what is runoff? Now, runoff is no sewage water is being thrown in there, but there are slopes on which the rain takes place and the water flashes down, gets into the lake. It's called runoff. And that runoff doesn't only have, in case of Sukna, the bulk of it is silt, but in many cases, it can have the excreta of animals. It can have some biomass which comes along with it, submerges into the lake, and then it rots there. So it can bring a lot of contamination, which is biological in nature. So one method is that you build a garland drain around the lake. Whatever water comes, it goes into the drain, flows off, bypasses the lake. Or it has an upward flow, which is filtered, and then only filtered water goes into the lake. It's expensive, but it is very effective. The best example, I've seen it, that garland drain itself is a filter. So whatever runoff water comes, it gets filtered, and you keep on cleaning periodically, right? Then use of organic flocculants. What is a flocculant? There are certain materials which you put in the water. They absorb all the filth around, and then they settle down. Or sometimes they come up as a scum and then they are just skimmed off. So it results into taking out the contaminants from water. So you can use some flocculants also. But the most interesting and most effective method is the next one, which is called aeration and oxygenation for water quality. And this is where the nanobubble technology is the best possible solution. Aquatic biomass harvesting. There is a lot of biomass. If you look at this lake, when I proposed to the Chandigarh Smart City that we can make your water transparent by using nanobubble technology, one of the officers in confidence told me that will create more trouble for us, because then the aquatic biomass below will become visible. And in Chandigarh, people are very agitating. They will raise issues about it. There is so much of jungle below the lake, which today is not visible because of the mud. So it's very interesting that they don't want this water to be transparent. It will expose them. Now, very important is to harvest the biomass. So just like you have the field harvesters in our farms, which clean out the crop, they cut it from the root and then take away the biomass. You can run similar water harvesters. I will show you some pictures, maybe if possible. And then you can remove the dredging and the silt and also the biomass along with it. Then most important thing would be to monitor the water quality at the mud-water interface. At the bottom, how much is the air or oxygen in the water near the bottom? That is very, very important. Because if that is zero, then there will be no aquatic life. And then we have standard bioremediation techniques, which cannot discuss today in this session. So let's go to the next. We discussed briefly the aeration techniques already. The surface aerators, fountains, movable jet aerators, fixed ceramic cores, fine diffusers, membrane type fine bubble diffusers, micro bubble, micro nano bubble, and nano bubble diffusers. And then is the hydrosonic gas fluid diffusion. Have a look at this picture. If an ordinary bubble, which is the macro bubble, diffused from bottom, it rapidly goes up, bursts at the top. So some oxygen transfer does take place, but very little. If it is converted into a smaller bubble, the hole is small, and you get a small bubble, it goes up slowly, gets consumed by transformation into oxidizing the water, and it disappears somewhere near the top. But if it is a nano-sized bubble, which means 100 or 200 nanometer size of a bubble, it never goes up because of this surface tension and keeps floating inside for weeks and months together. Another thing is that if you have a nanobubble, you can have 10 million or billion nanobubbles per liter of water. So its efficacy is almost many thousands times the normal efficacy. To understand the word nanobubble, let us say, if the cavity from which the water is coming, the gas is being fed to the water or air in this case. Normally we have 1 millimeter size bubble. It will be visible. The bubble is going up. When you have less than 100 micron size, it becomes cloudy. It would not be visible, but it will form a cloud. But the moment it goes below 100 nanometers, it will be transparent, but scatter light. If you put light, you can see that, but otherwise it is not visible. So let us understand that a nano bubble is very, very effective. And if we try this nano bubble in the lake, it is estimated that within 2 to 3 months, it can become a clear water lake. Of course, many other initiatives have to be taken along with it. Let us just roughly, you need not remember them, but nanobubble saturates water almost 80,000 times that of oxygen in traditional aeration. It controls the algae nuisance, mitigates excess nutrients and harmful toxins, sustains rapid growth of beneficial bacteria and microbes, prevents anaerobic bottom muck and sediments, can stay within column for more than 2 to 3 months, almost 4 times greater BOD removal. BOD is the biological oxygen demand. Whatever pollutants go into water, they demand oxygen from water. So a high BOD means bad quality of water. So this removal of BOD, it will be 4 times faster than traditional methods. And more than 80% of these suspended solids will be removed. That's why I said it will become a clear water lake. Better visibility, overall water, wastewater clarity, and up to 70% reduced energy consumption. The energy consumed here would be 70% less. That is the most interesting part of it. So when we're talking smart, we not only have to do this 80,000 times more effective treatment with so many of advantages, but ultimately we need to do it at a lower cost. Only then it is smart. Otherwise, you go on supplying more and more and more of oxygen, and sometimes it will become clear. No, we can't afford that. So we need to have a method where not only does it at a lower cost. So the nanobubbles in general, just running through it, less than 200 nanometer size, and then their oxygen transfer efficiency is extremely high, about 2000 times that of the other methods. They don't actually go up, they keep floating and they entirely get consumed. They get dissolved in water and then oxidize it completely. The transfer would be as high as 90 few percent. Nanobubbles are very stable and can remain suspended in water for several days, even months. And then they have an ability to highly reactive free hydroxyl radicals that give nanobubbles the property of rapid oxidation to remove organic material efficiency. Now see this specific examples of certain lakes which have been treated this way. So on left side there is something before treatment, and on the right side is after the treatment. You can see the difference. And what has been done is, aeration. Now, some of them have been aerated by microbubbles, some of them have been aerated by nanobubble. The bottom right is nanobubble. So it is, you can see it is very, very clear water. This is a little more technical thing, subcritical water treatment technology, but I would be skipping over it. I don't wish to burden you with the excessive dose of technology. But basically what it means is when you're treating the sewage, you're left with sewage sludge. That sewage sludge is a very concentrated pollution load. And that has to be treated in this reactor to make compost. And this is an example of using this compost for plantation. And this is very successfully done. And it has many other applications which we cannot take up in this session today. Now, very important is the eco materials, which I mentioned to you already. And the criteria is that we should not use scarce or hazardous raw materials in construction, functional ability to clean and conserve, low environmental impact during manufacture. Now, if you start making, for example, cement takes a lot of energy and a lot of environmental impact during its manufacture. So something which can replace cement is definitely. So in our road construction industry, we generally use tarpaul instead of cement. That is because we are using a waste to do the same task, and which is having in fact, a utilization of a waste rather than creating cement at a high environmental cost. So that's a good replacement. It should provide high performance, longer lifespan, and should be easy to recycle. So this is generally the eco materials which we must prefer. And some of the materials, they have to be renewable, recyclable, non-toxic, non-hazardous, locally available, secondary derivatives, and then ideally generated from waste. This is a general criteria, broad, how we call a material eco material. Functional objectives should be higher strength, longer life, durability, low environmental impact, energy efficient manufacture and use, enhance natural light and energy use, provide high degree of insulation, and ensure total recycling. Not only they should be recycled or let us say from manufactured from waste, they should also be recyclable for future. That is also important. So key sectors of sustainable infrastructure therefore would be city development and building, roads, rails, bridges, ropeways, energy generation, transmission, distribution, wastewater treatment, municipal waste disposal system, sustainable mobility, tourism, civil aviation. Now, tourism and civil aviation, very important. Only if you have the solar boats rather than the motor boats, it's a big service done to the lakes and reservoirs, and industry and services should also be so well designed. And now this is an example of practical eco materials. This is a solar tile. Can you see this? Now this is on the right. This is a typical Kyoto ceramic tile. There in Japan, they have the blue ceramic tiles for roofing. And it is having a solar panel, these blue lines which you see in the lower portion, they are the solar panel. And they gather the sun and produce electricity. And the rest of the frame, it absorbs sunlight, heat from the sun, and then it transmits it below that for the keeping houses, because they are cold regions, so it keeps the house warm. And by just choosing a right kind of material, solar roofing, they achieve efficiency in a total perception. So this is an example of a solar building. I told you, you can do it on the roof, you can do it on the walls, you can do it on the windows. So this is one of the best examples of solar energy efficient building. Even in India, you can see this to your left is a building in this is DLF tower in Gurgaon, and you can see it on the right, allowing all the sunlight to come in. So you don't have to use lighting inside your office, right? So it is all, you can have plants grown inside. This all nature friendly. And the best example in India is the CII Godrej Green Building Business Center, which is in Hyderabad, which is probably so far the best. It uses, even the toilets are eco toilets. That's another format. But do not forget this point, which is very important. Over 25 billion tons of materials originate from the waste, the construction waste. The construction waste, which is a nuisance, can also be used for construction. So that is very important, that normally this was one area which was forgotten. So all that construction waste in the past was thrown inside the dumping areas or these landfills. Now it is not so. They are all recycled. They are again remanufactured and then used in construction industry. And we call it sustainable concrete. So crushed glass, wooden chips, slag, they can all be added to make sustainable concrete. It reduces the environmental impact. Now, this is a very interesting example and very, very interesting. You will find it very easy, but it is very interesting. Rather than using a light inside, there's a bunch of fiber, glass fiber, which is being used. And on rooftop, it gathers the sun, and then the light is transported through these fibers, and the tips start glowing brightly. So you get all the sunlight which was above the roof, cut off by the roof, and then transported through the glass fiber. So this is a very innovative lighting system inside the buildings, which can be used. The smart advanced materials for sustainability are now summed up as smart materials, advanced coatings. Advanced coatings because, if your external coating of the building is such that it reflects the sunlight rather than absorb it, then your air conditioning costs are reduced. It should be biocomposite materials, memory polymers, thermoplastics, specialty alloys, nanomaterials, carbon fibers, and nanocellulose. I'm running through a little faster to save time because I want to touch upon the last one, the carbon fiber and the nanocellulose. One very important thing is aerogel. Now, this is nothing but a silica gel, which is amongst the world's lightest materials. It is lighter than air almost, and the insulating properties are huge. So in US, you find a lot of buildings which are glass buildings. They are not actually glass buildings. They are the glass slabs sandwiched with aerogel in between. So that aerogel gives the insulation, and it is transparent enough that you can see through the building, and they appear to be glass buildings. It feels like a polystyrene, very light, very strong structure, remarkable thermal insulation, good convective inhibitors, good conductive insulator, good radiative insular. And sound absorption is also, it saves you from the noise pollution. You can see on the right, there is a silica gel sheet below which there is a torch flame, and someone is touching this on top, and he's safe. This flame is almost 900 degrees Celsius, and the finger is being put on the top of this sheet, and he's comfortable. So it is that strong an insulation. You can imagine the kind of energy saving it can make. You can have actual application of the panels made of silica gel for your glass houses. You can see this is all silica hydrogel panels. This building is constructed inside. So it gets the light, it doesn't get the heat, and it is a very convenient eco material. Very important one is carbon fiber or fabric, because if carbon fiber is far lighter than steel and much stronger than steel. So already all the high-end cars globally, particularly racing cars, now are made of carbon fiber. All aircraft which was earlier made of metals are now made of carbon fiber because they become lighter and they are more aerodynamic. So you can see, that carbon fiber is lighter, is stronger than steel. So it is replacing steel in many areas. So we need to think how to use and where to use, particularly when you're making the earthquake resistant highways or the metro rails. Then all the columns need to be reinforced with carbon fiber. They'll be many times stronger than steel. Yes. Now, there is a next generation material, which is more interesting than carbon fiber. Now, this is something which is called nanocellulose. See, when we make paper from forest, let us say timber, it has cellulose and lignin, two components. Lignin is removed, and paper is what? It is cellulose. Now, if you go on refining that cellulose and bring it to the nanofiber level, then spin that fiber, you can see this. The first example was a bicycle. You can see, yes, this bicycle frame is made of nanocellulose fiber. So you can lift it with one finger. It is so light, but it is stronger than steel. It is stronger than even carbon fiber. Your tennis racket made of nanocellulose would be much stronger than a steel or a carbon fiber bracket. And at the bottom right, you can see a car. It is not actually on the market, but it is the stages of development. That the entire car body would be made from the nanocellulose fiber. So it will be stronger than steel. It will be lighter than carbon and steel. And the day is not far when aircrafts will be made from nanocellulose, which is something very similar to, in your school, you must be throwing the paper planes on your class fellows. So you will actually see that paper is making aeroplanes in coming years. It's not very far. So future also lies in bio-based materials. All these plastics which you are seeing here, they're made from biomaterials. And why biomaterials are important? Because they are renewable. When you are using bioplastics, not the petroleum-based plastics, you are not depleting the petroleum resources. These are cultivable, they are annually replaceable and then usable. So it's a renewable material, it's not a scarce material anymore. So building smart cities is a continuous process that never ends. And all it needs is innovative mind, much more than knowledge. Thank you very much. And I would invite questions, any of you. And I would love, if not questions, don't bother, give your suggestions. They are more important. If you have.
Thank you so very much, sir. Thank you very much, sir, for your wonderful presentation and enlightening our participants with this very informative and detailed information that you have shared with them. So students, if you have any questions, just drop the questions in the chat box. Any questions or suggestions you have, you can drop in the chat box. And at the same time, you can raise your hand if you want to ask something from sir regarding the presentation, regarding today's topic. So in the meanwhile, I would just like to thank you that in spite of your poor health, you managed and you delivered this talk, and students, they could take the benefit of learning that what actually a smart city is and how we can make our city smart. जैसा कि सर ने एक आपको बोला वेस्ट ट्रीटमेंट प्लांट जो है, अगर आपने नहीं देखा तो we have a sewage treatment plant at Science City. You can come to Science City anytime. And those students who visit Science City under environment studies come for the field visit purpose here, and we show them that how the sewage treatment plant and rainwater harvesting system works, because we have here at Science City both the facilities we have. So students, if you have any questions, just drop the questions in the chat box. So I think they are just trying to grasp the whole information.
Yes. Yeah. No question means two implications. One, they have understood everything. The other is they have not understood anything.
So anyways, though most of the students, they do ask questions, or what I'll do is, if they have any questions, they can drop me those questions in the group we have made, and I'll forward it to you on your email ID. And so it's time to.
Okay, you can give them my contact to them, and anybody. It is most interesting for me to talk to the youngsters rather than teachers or seniors.
Sure, sir.
Who have already learned enough.
I'll do that.
Yes, and
some of the students, they wanted to share their ideas, but then due to time constraint, we'll not be executing the things now. We'll be doing it on Monday. We'll organize another session, particularly for idea sharing on Monday at the same time. So, so we have a feedback about today's about your talk. There's a person from Government Girls Senior Secondary School, Batala. They're saying that very informative lecture, sir. Kudos to you, and kindly give us link of. Okay, So this I'll provide, beta. Link I'll provide, and the recording I'll share with you. So thank you so very much, sir. It's time to propose formal vote of thanks. So, sir, our heartiest thanks. So आपने अपनी खराब तबीयत के चलते भी बच्चों के साथ इतनी डिटेल में जाके उनको ये चीज समझाई कि कैसे we can make our cities smart, और बहुत सारे ऐसे मेजर्स के बारे में बताया जो बहुत नए हैं. इनफैक्ट मैंने भी कई चीजों को उनमें से आज पहली बार सुना है. So thanks a lot for being with us today. Thank you very much, and I would like to thank our participants also. Thank you very much, students, for being with us today. And yes, idea sharing पे जो session है, we will organize it on Monday. So आप अपना वहाँ पे भी presence जरूर देना. So thank you very much, sir, once again.
Thanks a lot. Thanks a lot. All the best.
Thank you.